Hey guys, happy weekend. Today we are working on 6.4, the ambiguous case. Okay, now let me give you what the ambiguous means, that there are many interpretations. Okay, so if you were to look up what that word meant, that's what it means. Okay, let me give you a little bit of background discussion points. So you might want to just put this like on a box on the side of your notes. Okay, so when you're given side, 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 or side, angle, side, you are going to use the law of cosines. Okay, so when I give you some information on a triangle and you're to graph that, you may have noticed on your homework that side, 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 or side, angle, side, you'll use a law of cosines. Let me also put in there, or Herring's formula is also, you can use Herring's law as another option. If you use side, or angle, side, angle, or angle, angle, side, you're going to use law of sines. Okay? What about the ASS triangle? Okay, and you probably recognize this from geometry, and all you were told back in geometry was that the angle side side triangle does not exist. Okay, and let me show you the reason why. Okay, so you'll say what you'd be given is that angle A is, let's just go with 55. Side length C is 10, and then side length A would be like 2. What the drawing would look like is, here's my angle, here's 10, here's 55, and then here's 2. Okay, notice there is no possible way for me to make a triangle that satisfies those equations. Okay, but given it to look like that. But there is a specific time when it actually could work. Okay, so let me erase this real quick. So when your graph looks something kind of like this, there is no solution. Okay? Let's say we take that same angle. Let me make it try to look like the previous one. So if we have the same angle, same length of side, there is a time where the length of that third side could satisfy that equation. And in that case, there would be one solution. Okay. Last but not least, there's one more option. So this looks a lot like the first one. Okay, so there's the one solution, but there's another option that if we took this same length and pushed it in to where it would be the same length, the only thing that's changing is the length of that angle. So one's acute, one's obtuse. There's actually a couple times where there can be two solutions. So I'm going to show you how you can actually get two solutions there. Okay, so first example. Let's say we've got our triangle. A, which is 55. Let's say we have a side length of 25. Let's name this B. And say we have 7, notice is A here, and here's C, B. We don't know what the angle of C is, we don't know the angle of B is, and we know 25 is C. Okay? So we're going to use the law of sines. Okay? So we've got sine of 55 over 7 equals sine of C over 25, because we're trying to figure out what this angle is. Okay, we're going to cross multiply and divide. So you'll get sine of C. Go ahead and plug that into your calculator, and you should get 2.925. So we're going to take the inverse, or the arc sine, to get the measurement of angle C. When you plug that into your calculator, you will get an error message on your calculator. This is the case that there would be no solution. There is no possibility to make this drawing. Technically, I kind of drew it a little wrong. Like 7 is not long enough in order to create the third side. Okay, so no solution. The calculator would tell you that there's no solution. Okay, let's look at the next one. Let's take a triangle again. So we got 55 for A. Let's make length of A is 27. Still got B. We don't know what B is. We don't know what the measurement of angle C is. We know side length of C is 25. Okay? Again, we're going to do the law of sines. So sine of 55 over 27 equals the sine of C over 25. Okay? Once you plug that into your calculator, you're going to get the measurement of angle C is 49.33. So that is one solution. Now, to check to see if it has two solutions, remember sine, and this was back in December, we talked about sine. When you restrict the domain, sine can be in the first quadrant, and it also can be in the second quadrant. So you've got to take that 49, and we're going to subtract from 180 for the reference angle. When you do that, you get 130.67. Okay, so 130 degrees and 67, I was about to say cents, but that's not right. So 130.67 degrees. Okay, so our triangle, if this would work, oops, not look like that. It's an obtuse triangle. Okay, so this would be 130.67 and then 55. Okay, so what we're going to do is we're going to add, because we got to figure out what the measurement of angle B is. So we're going to do 180 minus 55 minus 130.67. When you do that, what do we get? You're going to get a negative decimal number, which is not possible. So there is only one solution to example 2. Okay? Now, as you probably can guess, I'm going to show you how you get two solutions. So example 3. You got 25 for A, B, Let's make BC 22. Oops, that's not B, that's A. Oof. Okay, let's still make angle A is 55. Okay, we are going to do law of sines again. Cross multiply, divide, and you get the measurement of angle C is 68.57 degrees. Okay, so we know that that is one answer. Okay, you always have to check. Oh, Miss Polson's calling me right now. That's funny. So I know Rachel's going to love that. I'll call her back. But we've got, so that's one answer. So let's check for the other answer. And if you remember, you're going to take 180 minus 68.57, and we will get 111.43 degrees. Okay, to check to see if that actually makes a triangle, you have 111.43, 55. So you're going to add these two angles and subtract from 180, and you get 13.57 degrees. So it's a very cute angle, but that's how you get your two options. Now in our assignment on Monday, I'm going to have you take it one step further, and I'm going to want you to find the actual measurements of AC based off our new measurements. Okay, so you're just going to do law of sines one more time for each one of those. Okay, so that basically concludes our notes for today. Have a great weekend. Make sure you have all of your worksheets filled out and your notes ready, and I'll be checking them on Monday.